grade listeners, I'm Dr. O.O. Olubanwo. We'll be considering study session 8, which is complex number 1. In your previous class, my colleague that taught you talked about the binomial theorem while making use of Pascal triangle, also using binomial theorem to solve binomial equations. That is, when we have equations of higher degrees, you run down through, also did some applications using binomial theorem to expand some numbers. But in this session, which is session 8 of Math 101, General Maths 1, we'll be considering the complex number 1. Our learning outcomes for this study are to understand and classify complex number, 2, to find the conjugate of a complex number, 3, to perform different operations on complex number, and lastly, to present a complex number on the Alger diagram and add and supply a complex number graphically. What do you mean by complex number? Complex number is not different from other number. It only is an upgrade over real numbers. In complex number, we always have the real part and imaginary part. So by definition, a complex number is any number that can be written as a plus bi, where I is the imaginary units and a and b are real numbers. For example, if we have a plus bi, a is the real part, then b is the imaginary part of the number. As we have said before, complex number is an upgrade over real numbers, because in complex number we have the real parts and the imaginary parts. Classification of complex number. Now that you already know what a real number is, we can go and give a proper definition for imaginary number. An imaginary number is a complex number a plus bi, where the real part, which is a, is 0. Similarly, a real number is a complex number a plus bi, where b is equal to 0. Basically, when we have a number, if there is no imaginary part in that number, it shows the number is real. That is, it's a real number. But if the real part, that is our a, is 0, it means the number is an imaginary number. We can conclude from the definitions above that any real number or imaginary number is also a complex number. Nevertheless, there are complex numbers that are neither real nor imaginary, conjugate of a complex number. The conjugate of a complex number a plus bi is the complex number a minus bi. What we are trying to say is this: if you are given a complex number a plus bi, the conjugate of that complex number is by changing the sign that is beside the imaginary part. So the conjugate of the complex number a plus bi is a minus bi. In other words, it is the original complex number with the sign on the imaginary part changed. Operations in complex number. A lot of operations can be done in complex number. Now, we consider how to add, subtract, multiply, and divide complex number. Basically, all the properties or the operations which can be performed on real number can also be performed in complex numbers. That is, all the laws which real number preserves, complex number also preserves such. I hope we are still together. Addition and subtraction of complex number. The easiest way to add or subtract complex numbers is to think of each number as a polynomial and add or subtract in the exact way you do for your polynomials. That is, the way we subtract and add numbers in complex number also go in the same way we do for real numbers. Let's look at this example. Case study 8.2. Simplify. The first one, minus 4 plus 7i, then plus, open bracket 5 minus 10i. The second one is 4 plus 12i minus, open bracket 3 minus 15i. The third one is 5i minus, open bracket, minus 9 plus 1. Solution. Minus 4 plus 7i plus 5 minus 10i. Now, what we are to do here is this. We combine real to real and imaginary to imaginary. You put the real together and the imaginary together. So, minus 4 plus 5. Minus 4, because the real part here is minus 4 and 5. Minus, you know that when you add minus 4 plus 5, it will give you 1. It's like you are owing somebody 4 naira and you have 5 naira with you. So, when you settle that 4 naira you are owing, you have 1 back. Then, 7i plus minus 10i. That will be 7i minus 10i, which is minus 3i. So, the result for minus 4 plus 7i plus, open bracket, 5 minus 10i is nothing but 1 minus 3i. The second one, 4 plus 12i minus, open bracket, 3 minus 15i. This will give us this. You combine real to real and imaginary to imaginary. The first part, the real part is 4. Second one, the real part is 3. The first one, the imaginary part is 12. Then, for the second one, the imaginary part is 15. So, when you combine real to real, that's 4 minus 3. Then, 12i minus 15i. When you look at this, 4 minus 3 will give us 1. Plus 12i minus 15i. Minus and minus is plus. That's 12i plus 15i, which will give us plus 27i. So, the result for that one will be 1 plus 27i. Are we still together? Well done. The next one, 5i minus, open bracket, minus 9 plus 1. When you look at this problem we want to solve now, the first side, the first parameter there, you observe that we don't have the real part. We only have the imaginary part, which is 5i. It's like the real part is present, but it's hidden. Because 0 is also a number. So it means the real part there is 0. So it is 0 minus 9. 0 minus 9. And the other part is 5i minus I. So when you look at this, you have 0 minus I, that's 9, plus 5i minus 1. So when you look at this, you have 5i minus I. The next one, multiplication and division of complex number. The same procedure we carry out for the real part, for the real numbers, we also complete such in complex number. Now, you will multiply complex number as you do for polynomials. The little difference will come in the final step as we see below. You will multiply the first bracket by the second bracket. We have I squared equals 1, minus 1. Our I squared is minus 1. Case study 8.3. Multiply each of the following and write your answers in standard form. The standard form is in terms of A plus BI. Now, 7i into bracket minus 5 plus 2i. The second one is 1 minus 5i into bracket minus 9 plus 2i. Third one is 4 plus I into bracket 2 plus 3i. The last one on the list there is 1 minus 8i into bracket 1 plus 8i. Solution. Looking at the first one, 7i into bracket minus 5 plus 2i. When you look at this, 7i times minus 5, that will give us minus 35i. Then plus 7i times 2i, that will give us 14i squared. It will give us 14i squared. Recall that I squared is equal to minus 1. So if I squared is equal to minus 1, based on the concept of the imaginary, we have minus 35i minus, that will be plus 14 into bracket minus 1, which will give us minus 35i minus 14. Now, to write this in standard form, it simply means you write the real part first and the imaginary part later. So this will be minus 14 minus 35i. Again, it's minus 14 minus 35i. That is standard form for the first problem. Now, for the second one, we have 1 minus 5i into bracket minus 9 plus 2i. 1 minus 5i into bracket minus 9 plus 2i. Now, multiplying them term by term. 1 times minus 9, it will give us minus 9. 1 times plus 2i, it will give us plus 2i. Now, minus 5i times minus 9, that will give us plus 45i. Multiplying the last part, which is minus 5i times plus 2i, that will give us minus 10i squared. Now, let's review what we have here. Minus 9 plus, because 2i plus 45i will give us plus 47i. Then, we know that our I squared is minus 1. We have plus, minus 10 into bracket minus 1, which will give us minus 9 plus 47i plus 10. Now, when you now look at this, adding real to real and imaginary to imaginary, this will give us minus 9 plus 10. That will give us 1. It's like you are owing somebody 9 naira and you have 10 naira with you. When you sort that, the money you are owing, you are left with 1. That will be 1 plus 47i. Now, the next one. 4 plus I into bracket 2 plus 3i. 4 plus I into bracket 2 plus 3i. When you say 4 times 2, that is, you multiply them term by term. You multiply them the first one by the second. 4 times 2, that will give us 8. 4 times 3i, that will give us plus 12i. Then plus I times 2, that will give us plus 2i. Then I times 3i, that will give us plus 3i squared. Recall that I squared is minus 1. So we have 8 plus 14i, because 12i plus 2i will give us 14i. Then plus 3 into bracket minus 1, which will give us 8 plus 14i minus 3. So you combine real to real, imaginary to imaginary. So that would be 8 minus 3, which is 5, plus 14i. The last but not the least, here we have 1 minus 8i into bracket 1 plus 8i. 1 times 1 is 1. 1 times 8i, we have 8i. Minus 8i times 1 will give us minus 8i. So negative 8i times plus 8i. That will give us minus 64i squared. So 1 plus, because our, yes, 8i minus 8i is 0. That's 1 plus 0 minus 64 into bracket what minus 1, which will give us 1 plus 64, which equals 65. Now to write this in standard form, we have 65 plus 0i. The real part is 65, while the imaginary part is 0i. Listeners, multiplying a complex number by its conjugates gives you a real number. Yes, let's examine this. If I have a complex number a plus bi, the conjugate of it is a minus bi. Multiplying this, a times a will give me a squared. As you can see on the screen, a times minus bi, that will give me minus abi. Then bi times a, that will give me plus abi. Then lastly, bi plus bi times minus bi, that will give me minus b squared I squared. Looking at this, plus abi minus abi is 0. And recall that your I squared is minus 1. So we have a squared minus b squared into bracket minus 1. And that will be a squared plus b squared. Listeners, you can agree with me that when you are multiplying a complex number by its conjugate, we always give back to a real number. Powers of I. From knowledge of multiplication, my I raised to power 1 will give me I. Then my I squared will be I times I, which is minus 1. Then my I cube will be I times I squared. And I know I squared to be minus 1. It will now be I into bracket minus 1, which will give us minus I. Listeners, let's look at I raised to power 4. If we are considering I raised to power 4, this one is nothing but I squared all squared. So it simply means I'm having I squared times I squared. And since I know my I squared to minus 1, it's simply minus 1 times minus 1, which will give me plus 1, which can be written as 1. Then the next one, I raised to power 5, is nothing but I times I raised to power 4. And when you look at I raised to power 4, it is 1. So I raised to power 5 will now be I times 1, which is I. Now, looking at I raised to power 6, basically this can be written as I squared times I raised to power 4. From what we have here, our I squared is minus 1, and our I raised to power 4 is 1. Minus 1 times 1 will give us minus 1. Now, I raised to power 7 is nothing but I squared times I raised to power 5. I raised to power 7 is I squared times I raised to power 5. What is my I squared? Listeners, my I squared is minus 1, and my I raised to power 5 is I. So minus 1 times I will give me minus I. Last but not the least on this screen, I raised to power 8 is nothing but I raised to power 4 all squared. Or you say I raised to power 4 times I raised to power 4. When you look at the board clearly, you see that our I raised to power 4 is 1. So 1 times 1 will give us 1. You can see the pattern repeats after 4 powers. The pattern repeats after the 4th power. So listeners, we must be able to recap this whenever it is needed. Because there is no way when you are solving, when you are multiplying two numbers in complex numbers, you will definitely need to apply this. Also, when you are dividing, you need to apply this power of I. With what we have done here, I believe we should be able to add complex number. We should be able to recognize even what a complex number is. We should be able to look at complex number multiply them, and also we should be able to look at the powers of I irrespective of what we are given and decide. Thank you for listening. See you in the next study session. Bye.